Let's see. I'm Kirk Voelker. I'm a pulmonary critical care doc, director of clinical research at Sarasota Memorial Hospital. In the sake of time, I'm going to try to go fast on this. Set timer for 15 minutes. We're going to get a 20-minute presentation in 15 minutes. All right, disclaimers. No financial disclaimers. Opinions rendered are not reflected of that of FSU or SMH. And in fact, I'm not sure I'm not going to even take credit for the opinions I'm rendering. Come on. Oh, at the end of the talk, you'll probably have more questions than answers. So if you think I'm going to like settle some longing question in your mind, no, you're going to come out of here with more questions. And that's actually what I want you to do. I want you to ask questions about everything. Oh, I can look at that thing, yeah. Air pollution. As Stu was mentioning, I only have 4 here, but there are 5 things that the EPA looks at when they look at air pollution. And that is the carbon monoxide, ground level ozone, which Stu went over, nitrogen dioxide, sulfur dioxide, which are usually products of combustion, and that particulate matter, the PM 110, PM 2.5, PM 0.1. And just to give you a sense of what that is that the bigger the particle, the harder it is to go deeper into your lungs. So the PM 10s are things like allergens, and that leads a little back to Dr. Wazen's talk, where he was talking about the inflammation caused. The PM 2.5 go farther down into the lungs, and then the very fine particulate matter, the PM 0.1s, they can go not only into the far ends of the lungs, the alveolar sacs, but then they get into the bloodstream too, and they can wreak some havoc there. Let's take a look at ozone. Now, that's not a particulate matter, that is a gas. It's basically oxygen, which is O2, with an extra O on it. But that other O on its back causes all sorts of problems, causes free radical generation. It can cause interference with the lining of the lungs, the epithelium, the making of proteins, the actual way that our white blood cells, our defense system works. So this ozone can disrupt multiple areas in our basic human pathophysiology. Now, this slide was from 1997. Since then, we've actually evolved in medicine looking at other things, such as the DNA. Free radicals can damage DNA, which can cause problems in itself, like cancer. Ozone can actually affect what we call the epigenome. If DNA were your record, and the epigenome is the record player or the CD player, and basically that translates the DNA into proteins. And so ozone can disrupt that too, and affect your gene expression. Of course, the respiratory effects of air pollution, are sort of obvious. But if you think about it, when a child is exposed to the inflammation caused by air pollution, you can cause reactive airway disease. They can develop asthma. If there's continued inflammation, the airways get sort of floppy, and that causes something called bronchiectasis, which gives them problems for the rest of their lives. So cardiovascular effects, it can cause hypertension. Because of the inflammation that it causes, inflammation in the blood vessels in the heart can cause heart attacks. Inflammation in the blood vessels in the brain cause strokes. So there's a correlation there as well. Other health conditions in that it can cause Neurodegenerative disease. There is association with increases in dementia and higher levels of air pollution. And again, the whole systemic inflammatory response is whenever your organs get inflamed, they become dysfunctional. And air conditioning, air pollution can contribute to that. Who's at risk? Obviously, children, as we discussed, and the elderly, not casting aspersions on anyone in this room, and those with pre-existing conditions. But also people, let me just back it up a little bit. Yeah, and in the things that we're measuring, okay, I mentioned some of the things that, that air pollution could affect. We have sort of hard targets that we measure. And I'll bring up an article in a minute. If we look at things like hospital admissions for asthma or death in correlation with increased air pollution, those are sort of hard targets. But repeated exposure to air pollution may cause longer-term problems. And let's say we were talking about DNA or epigenome. That may not show up for months or years, or it might require, continuous exposure. So there are things that we don't know yet in medicine to measure that may still be at risk. How can I tell about my local air quality? Stu went over this very well with the airnow.gov, and you can dial in just there that I live in Sarasota, and it'll give you your air quality. So how do we measure pollution's effects on humans? And what we can do is take a look at biological samples such as blood or urine. Okay, and from there we can look at are there PCBs in it, heavy metals in it? Could it be that there are other volatile organics in that? There is, for epidemiology testing, they have developed personal air quality detection things, but those are expensive and not used very often. If we look at inflammatory markers, like I said, air pollution can cause inflammation, and that is sort of one of the common elements of many of the diseases. So you look at the inflammatory markers. Lung functions, those are breathing tests that we do as lung doctors. And when you think about it, the bigger particulate matter, the allergens, or tree pollution, get into the upper airways or into the bronchial tubes, can cause inflammation there, and that causes wheezing, asthma, coughing, that type of thing. As mentioned, we can look at things like hospital mortality data. And that's actually pretty good data because that's sort of binary. You're either dead or you're not. And we're pretty good at collecting that data. And epidemiological studies. For example, here's a epidemiological study on ozone. And it looked at the short-term mortality in 95 US cities over, about 14 years. This was published about 20 years ago out of JAMA. And basically what they came up with was a conclusion that for every 10 part per billion increase in ozone over the previous week, there was a 0.52% increase in daily mortality, and slightly higher, 0.64, if you had cardiovascular or respiratory problems already. So this was a link between increased mortality and increased ozone, which can cause all those things that I was talking about. Before you leave this, thinking, oh no, I don't want to go outside on days, that are in the red on my Air Now map. This was very statistically heavy, taking data from back when we had paper records. And, I read the article a couple of times and sort of just could not make it through the statistics frequently. Do I really believe this? I think they probably are onto something. I would not be scared to go outside based on this article. But if I was going to go to one of my legislatures trying to make the case for climate change, the human effect, I would definitely use this. It's been cited and referenced by, I think, 60 other articles. It was published in JAMA. But I don't want you to leave here thinking that with high ozone levels you can't go outside. However, there are people who are predisposed. If you have asthma, if you've got COPD, by all means, just like when the pollen levels are high, I don't want you going out because that can inflame. Yes, when the ozone levels are high, it's not a good idea. All right, and this comes to sort of the crux of the matter is how are we going to address the air pollution in the future? Well, one of the things is that we need to have better epidemiology. As I mentioned, that previous study was done back when we had paper records, right? Every hospital just about now has computerized records. The problem is delving into those records. Well, now we have supercomputers. We have AI. I fully expect that within the next decade, we are going to have some significant impact on modeling algorithms to predict the effects of different sort of pollutants on human health. We need to improve our physiology testing. There are, as I was reviewing for this, there are certain genotoxicity tests that I came across that are just now in development, in which you're able to see in a specific person that their exposure to formaldehyde is affecting this gene loci. And then when that formaldehyde is removed, some of the illnesses associated with that gene loci can be removed. It's not, it's early in the development of that, but I do expect in a decade that we will have a personalized medicine way of looking at individuals and then taking that, all that data and doing it in group cohorts, trying to make a better prediction about what's affecting us and how and what we can do about it. Proactive policy measures, that's what this whole thing is about. What can we do? Dr. Miracle gave a great presentation about, as physicians, what can we do to be proactive? How can we take interest in this? And what can we do to educate? New medications. Yeah, there are always new medications coming out that help inflammatory for, new asthma medications coming out. But you know what? If you're treating it after the disease state when somebody has asthma, the horse has already left the barn. You're much better preventing it than trying to treat a disease afterwards. And, new innovations are always on the forefront. Just yesterday, as part of getting prepared for this, I came across, article's not there. Anyways, came across an article that was on a concoction of green bean sprouts, green Brussels sprouts actually, for green Brussels sprouts that help, that was done, a study done in China, the Hehe township of Zhenghua, China, which has high pollution. It demonstrated that those who had this green Brussels sprout concoction, they detoxified. There was more of these polycarbonate toxic products from air pollution that were excreted through the urine when they took that. And so it's interesting. I mean, by far, it's not, that I'm going to recommend that for everybody, but I would say that maybe my patient who was nervous about going outside because of the air pollution, that would be a good person to try this on. But what I'm saying is that the more we know about what we're dealing with, the more we'll be able to come up with ways to intervene on that. And I've got 6 seconds left. How do you like that?